Okay.
Sir, can we start the meeting, sir?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Good evening to all the participants and a hearty welcome to a 1 week online international workshop on enhancing computational skills of mathematics in various fields of engineering from 18th to 23rd December
వాడితో
2023.
చెప్పారు
In
చెప్పించారు
the
Sir,
fast
voice is
growing
not
field
audible,
of
sir.
engineering, computational skills have
Hello.
become the cornerstone of innovation and progress. Thank you all participants for joining with us to get an immersive experience that goes beyond textbooks, equipping you with the tools to navigate real world challenges through the lens of advanced mathematics. This international workshop will definitely redefine the way in which the students pursue and apply mathematics in their engineering journey. The aim of this international workshop is to bring some sort of awareness and enlightening the knowledge on support vector machine, mathematical models in engineering, descriptive statistics, visualization of mathematical concepts, statistical inferences, and robust computing. This week is a special week for all of us in which 136th birth anniversary celebrations of a great mathematician, Sri Srinivasa Ramanujan, in view of his birthday on December 22. He is one of the greatest mathematicians of India. Ramanujan's contribution to the theory of numbers has been profound. He was indeed a mathematical phenomenon of the 20th century. This legendary genius of India ranks among all the time greats like Euler and Jacobi. Sri Srinivasa Ramanujan's life remains a remarkable role model of innate mathematical genius, overcoming challenging circumstances, leaving an indelible mark on the world of mathematics. I now request humbly our senior faculty member and professor of mathematics, Dr. P. Vijay Sardi sir, to compare the program.
Okay. Thank you, both Raju. Good morning, good evening, all. A very warm and healthy good evening to our respected greatest mathematical geniuses. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and infinite series. His life and work continue to inspire mathematicians and scientists. Moreover, his life is often cited as an example of extraordinary mathematical intuition and talent. To pay our homage to him, the Department of Mathematics, Bapatla Engineering College, is organizing a 1 week online international workshop on enhancing computational skills of mathematics in various fields of engineering through virtual mode. This program is scheduled every day from 3 p.m. to 5 p.m. from 18th to 23rd December 2023, except on 19/12/2023 from 4 p.m. to 6 p.m. I am very happy to inform you that more than 1300 BTech students are participating in this workshop from Bapatla Engineering College and also from Bapatla Women's Engineering College. The objectives of this workshop are to foster a culture of continuous learning in student community by familiarizing the applications of mathematics and international universities, to convert young engineers into strong individuals in order to face the real world challenges by exposing them with a variety of lectures, both in mathematics and statistics, in different domains. On the first day, that is 18th December 2023, Dr. L. Jagannathan Sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, will deliver a talk on support vector machine A classifier. On the second day, that is 19th December 2023, Dr. P. Nagarani Garu, Senior Lecturer, Department of Mathematics, the University of the West Indies, Mona Campus, Jamaica, West Indies, will deliver a talk on Mathematical Models in Engineering. On third day, that is 20th December 2023, Dr. Y.N. Reddy Garu, Professor Emeritus, Department of Mathematics, NIT Warangal, will deliver a talk on Mathematics for Robust Computing. On the fourth day, that is 21st December 2023, Dr. M.A.S. Srinivas Garu, Professor Emeritus, Department of Mathematics, JNT University of College of Engineering, Science and Technology, Hyderabad, will deliver a talk on visualization of mathematical concepts. On the fifth day, that is 22nd December 2023, Dr. G.Y. Sagar, Professor, Department of Statistics, College of Natural and Computational Sciences, Gambia University, Ethiopia, will deliver a talk on Introduction to Statistical Inference. On the sixth day, that is 23rd December 2023, Dr. T.S.R. Murthy Garu, Professor, Department of Mathematics and Statistics, Sri Vishnu College for Women, Bhimavaram, West Godavari District, AP, will deliver a talk on descriptive statistics, analyzing and visualizing data. Now I request one of our staff organizers, Mr. K. Nagamani, to give a live sketch of Sri Srinivas Ramanujan Garu.
Good evening, all. Srinivasa Ramanujan was born on December 22, 1887 in Erode, a town in Tamil Nadu, India. His early life was marked by a passion for mathematics and an extraordinary ability to grasp mathematical concepts on his own. His formal education was at the town higher secondary school in Kumbakonam, where his interest in mathematics began to flourish. Despite of showing exceptional talent in mathematics, Ramanujan faced financial difficulties that affected his education. He attended Government Arts College in Kumbakonam but often neglected his other subjects in favor of mathematics. During this period, Ramanujan continued to independently study advanced mathematical concepts and worked on his own theorems and ideas. His lack of formal training did not deter him from making significant contributions to the field. Ramanujan's breakthrough came when he began corresponding with British mathematician G. H. Hardy in 1913. Hardy recognized the brilliance of Ramanujan's work and invited him to England. In 1914, Ramanujan traveled to Cambridge where he collaborated with Hardy and others. During his time in England, Ramanujan made significant contributions to number theory, infinite series, continued fractions, and other areas of mathematics. Even he faced challenges such as cultural differences, health issues, and financial constraints. Ramanujan's work continued to gain good recognition. In 1919, Ramanujan turned to India due to declining health. He was diagnosed with tuberculosis and other health issues. Srinivasa Ramanujan passed away on April 26, 1920 in Kumbakonam, India at the age of 32. His legacy lives on through the numerous theorems, formulas and concepts he left behind. Theorems such as the Ramanujan's Hardy number and Ramanujan's prime highlights his profound contributions. Srinivasa Ramanujan was extraordinary mathematician who made significant contributions to mathematical analysis, number theory, infinite series, and continued fractions, etc. His notebooks containing a wealth of mathematical discoveries continue to be studied by mathematicians, and his contributions have left an enduring impact on the field of mathematics. Srinivasa Ramanujan received several honors and awards in recognition of his valuable contributions to mathematics. Srinivasa Ramanujan was elected as a Fellow of the Royal Society in 1918, becoming the first Indian to receive this prestigious honor. His fellowship with the Royal Society is a significant recognition of his contributions to the field of mathematics. Hence, the Government of India declared December 22nd as National Mathematics Day in 2012, marking the 125th birth anniversary of Srinivas Ramanujan. The declaration aims to promote the importance of mathematics and its applications in various fields. It also serves as a tribute to Ramanujan's extraordinary work and his impact on the world of mathematics. Thank you.
Thank you, Mrs. K. Nagamani, for your informative life sketch of Sri Srinivasa Ramanujan Garu. Now I request our staff coordinator, Dr. M. Balaya, to present the department profile.
Thank you, sir. Respected Principal Dr. Nazir Sheikh Garu, our beloved HOD Dr. KVRN Acharya Garu, and my dear students, a very good evening to one and all. It is my privilege to present the profile of Department of Mathematics of Bapatla Engineering College. The department was established in the year 1981, in which the college was started. The department, which was originally intended to cater to the needs of college, the needs of engineering, offered an MSc Mathematics course with an intake of 40 students in 1989. The department was recognized as a research center by Acharya Nagarjuna University from the academic year 2003-2004. The department got name and fame under the leadership of former HOD Dr. Nagal Prabhakar Rao Garu. So far, the department produced 3 PhDs and 13 MPhils. The department was recognized as one of the potential departments in 2002 by the National Board of Higher Mathematics, and as a part of it, the department has been receiving quality books in mathematics, which are very useful for students and staff for their higher learning and in their research. The department is now enriched with 6 PhDs and faculty members from different universities. The college library has a collection of 1,323 titles and 4,618 volumes. Out of 32 MSc Mathematics passed out batches, 12 students achieved university first ranks and 4 students obtained university second ranks. 2 students received Pratibha Awards. For last 1 decade, 200 research papers were published in national and international journals. The major contribution has been given by Dr. KVLN Acharya sir with 145 research articles and Dr. N. Rafi sir with 45 research articles. Faculty members in the Department of Mathematics attended more than 150 FDPs, workshops, conferences, and seminars. Notable achievements are accomplished by the faculty members. In particular, Dr. KVLN Acharya sir created 3 unique world records in the field of mathematical research and honored with many awards and rewards. He authored 5 books and 10 chapters in various international publications. Dr. KVLN Acharya sir edited more than 150 books as editor-in-chief in various esteemed international journals. Faculty members in the Department of Mathematics completed 12 online NPTEL courses for enriching their knowledge. Recently, Department of Mathematics organized an international FDP with 800 participants throughout India successfully. Thank you.
Thank you, Dr. Balaya. So welcome to our principal, Dr. Nazir Sheikh Garu. Good evening, sir.
Namaste, sir.
Sir, good evening. Good afternoon, sir.
Now I request our head of the department and convener of this international workshop, Dr. KVLN Acharya Garu, to address the participants on this occasion.
Good evening to all. On behalf of the Department of Mathematics, I humbly welcome all of you to this international workshop. I extend a warm and heartfelt welcome to our beloved principal, Dr. Sheikh Nazir sir, my respected and eminent teacher, Dr. L. Jagannathan sir, my esteemed colleagues and my dear students. It gives me immense pleasure to take this opportunity to say a few words as a convener of this international workshop and head of the Department of Mathematics, Bapatla Engineering College, Bapatla, on this remarkable occasional week of birth anniversary celebrations of Sri Srinivasa Ramanujan, who is applauded as a world greatest mathematician. Sri Srinivasa Ramanujan made significant contributions in the field of mathematics, particularly in mathematical analysis, number theory, infinite series, and continued fractions, etc. He independently discovered many theorems and results that were later proven by professional mathematicians. Ramanujan's legacy is marked by the Ramanujan Hardy number, Mach theta functions, Ramanujan primes, and various other mathematical concepts named in his honor. Hence, based on his valuable contributions to the field of mathematics, we are celebrating his 136th birthday anniversary celebrations on December 22 in this week as National Mathematics Day. It is my duty to express my special gratitude to our magnanimous management, particularly Sri Muppalneni Srinivasarao Garu, President, Bapatla Education Society, and Sri Manan Nageswarrao Garu, Secretary, Bapatla Education Society, and other governing body members for their valuable encouragement to organize student-oriented useful programs. We are all thankful to our beloved principal, Dr. Najee Sheikh sir, for his timely guidance and valuable support whenever necessary. We feel very proud to work with him and render our services under his dynamic leadership for enriching the name and fame of our Bapatla Engineering College. The main purpose of conducting this international workshop is to focus on enhancing the computational skills in students' community in various fields of engineering. No doubt, improving computational skills is crucial for all BTech students. Our revered resource persons can share insights into how computational skills are applied in real world situations and motivating students to improve their skills. By combining theoretical knowledge with practical applications and exposure to real world challenges, BTech students can develop strong communication skills that are essential for getting success in their respective fields in future. Hence, developing problem solving skills and a deep understanding of computational principles will enable the students community for facing and handling the challenges confidently in their engineering fields. This international workshop definitely enriches the computational skills in students community for enlightening the knowledge of problem solving capabilities which are useful to all engineering sectors, software field, and also for their higher studies. So I strongly believe that this program will be definitely a fruitful one with the active participation of our sincere students. Today, we have a wonderful resource person with us. The resource person for today's section is Dr. L. Jagannathan sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. He is one of my best teachers in my students' career. Dr. Jagannathan sir is not only an inspiring teacher, but also a source of motivation, guidance, and unconditional support to the students' community. I had a good association with him as his student and also as a colleague. He rendered his valuable services to Bapatla Engineering College from 1994 to 2004, more than 10 years. He inspired plenty of students in his career with his best way of teaching and good qualities. On behalf of Department of Mathematics, I express my sincere thanks to my great teacher, Dr. L. Jagannathan sir, for graciously accepting our request to deliver his valuable lecture in our international workshop. Sir, thank you very much. Finally, it is my duty to conclude my speech by remembering a great and inspiring person, former HOD Dr. Nagalla Prabhakar Rao Garu, who made our Maths department very strong with his valuable efforts. All the best. Thank you, one and all. Sir?
Thank you very much, sir, for motivating our participants. Thank you very much, sir, for motivating our participants by explaining the importance of workshops. Now I humbly request our beloved principal, sir, Dr. Sheikh Nazir Garu, to give his valuable message on this memorable occasion. Sir.
Thank you, sir. Respected Head of the Department Mathematics, Bapatla Engineering College, Dr. KVLN Acharyalu Garu, and convener of 1 week workshop, international workshop on enhancing computational skills of mathematics in various fields of engineering. And today's our senior most and resource person, Dr. L. Jagannathan sir, School of Computer Science and Engineering, Vellore Institute of Technology, co-convener Dr. Vijay Sardi sir, senior most professors T. Srinivasarao Garu, and other mathematics faculty members, and all the my dear students and participants. A very good afternoon to all, and a welcome to this 1 week international workshop. Really, it's very inspiring to all of us when our head of the department, Dr. Kevil Nacharlu Garu, shared that more than 1,500 students are registered for this workshop. That number itself is motivating all of us, so which gives a inspiration to conduct more and more workshop. And I'm very much sure that the coming 1 week, all the sessions definitely which will be very useful for all the participants. Definitely, which will be a very joyful and useful sessions will be given by all the eminent resource persons. With this connection, I congratulate and appreciate the Department of Mathematics, head of the department, and all the faculty members of Department of Mathematics for organizing this kind of workshop. Recently, a faculty development program successfully conducted international faculty development program organized by the Department of Mathematics. In a 10 days of time, they won one more workshop to the student. Really, I appreciate to the Department of Mathematics for organizing this kind of event. So, without taking much time, we all are waiting for the our senior most professor Jagannathan sir. Sir, good evening, sir.
Good evening.
Sir, really, we are very happy, sir, for accepting our Department of Mathematics invitation. We are pleasure to see you, and we all are awaiting for your lecture, sir. Thank you, sir. Thank you, one and all, and I wish you all the best, all the participants.
Thank you.
Thank you, sir. Thank you very much, sir.
Thank you very much, sir, for your inspiring speech. Thank you, sir. Now, this is the time to know about today's resource person. Now, I request one of our staff organizers, Mrs. K. Nagamani, to present the profound profile of Dr. L. Jagannathan, sir.
Good evening, all. Welcome you all to a 1 week online international workshop on enhancing computational skills of mathematics in various fields of engineering. It's my privilege to introduce today's resource person, Dr. L. Jagannathan Garu. Dr. L. Jagannathan is a senior professor working in the School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. He obtained his PhD from Indian Institute of Technology, Madras, with a specialization in theoretical computer science. He is a passionate teacher, having explored many learning methodologies like J2A approach, project based learning, research based learning, flip the class, etc. His courses are oriented more towards triggering the young minds to think, and all his courses related assessments are a real minds on sessions. With his 32 years of teaching strong experience as an educator, his present research focus is on AI for education. At present, he is working in a mighty funded project to develop AI tools to facilitate education in a more better way towards making the concept education for all a reality. Professor L. Jagannathan Sir is applauded by one and all with his best way of teaching for the last 3 decades. He took an active part in designing and introducing new courses of advanced learning. He rendered his valuable services to wit in a different positions as head and dean or marvelous. His inspiring character, motivational behavior, teaching abilities, research capabilities, extraordinary communication skills are additional qualities in him apart from his goodness and vast experience in the field of education. Thank you all.
Thank you, Mrs. K. Nagamani, for your nice introduction about Dr. L. Jagannathan, sir. I know that you are all eagerly waiting for the lecture on support vector machine A classifier. Hence, I will hand over the session to Dr. L. Jagannathan, sir. Sir, please.
Good afternoon to all of you. Before I start the drama, let me 1 or 2 words because Bapatla has got embedded in my brain. So it is a place, it was a turning point when I worked in 1994 to 2004. And it was a really turning point. I learned a lot from Bapatla Engineering College, the environment, the town, everything. I like it. Even now, I don't have any regrets for having served in BEC and other things. Really, I enjoyed each and every moment of it. And really, that too, Actually, I don't know whether the senior professors will remember that during my period at Bapatla Engineering College, the concept of celebrating the Srinivasa Ramanujan's birthday got enacted in 1997, I think, if I remember correct, for 4 or 5 days with all the exhibitions. And the present HOD, Dr. Narasimham, was a MSc student there. I really enjoyed. And 4 days, 5 days in the drawing hall in the first, second, where the CAT exam, where the exams are going to, I forgot the room number and other thing. We conducted an exhibition, and even all the mathematical concepts were converted into a product with the help of carpenters, electricians, circuit makers, everything. Hope all can remember it. And that too, I was invited again during the Ramanujan's birthday after 19 full years. Really, that was a great credit for me. And Bapatla, that is, the people would have called that his master's voice, like M.S. Subbulakshmi's voice, gramophone recorder. I think my voice is being heard in Bapatla after 19 full years. Really, that is a great credit. I really cherish every word of mine. At the same time, I have a tension in my new avatar. I don't know how my feedback from the students is going to be. I don't know. In the old avatar, I don't know what feedback I got, and because that was a non-digital tech era. 19 and during 1994 2004, the student will write something and we'll forget the next day because we can't have a record of all the thing. Now in the digital era, I don't know how my feedback is going to be, but I'll have it. If there are any shortcomings, I'll try to correct myself. And hope I thank the organizers, Bapatla Engineering College management, principal, head of the department, and all the senior professors who are working there for having remembered me and having called me to give a talk. Really, that itself is a great credit for me, leave alone other things actually. Whether I am able to meet up to your expectations or not, just we have to wait and see. We'll make it out. I hope for the best, and I think that I can meet the expectation of it. And with these words, with all the thanks to all the organizer, everything, let me start it and let me upload my slide thing. And the idea here, the thing is, I request all the participants to have one scribbling pad or two or one sheet of paper with you, so that certain things I'll explain the transition phase, and this content which I am presenting today will be sent to all the participants, so that you can, minute details, you can make it out. I think the time is 3:30. I can go up to 5 o'clock, or for 5 o'clock, or 5 o'clock plus question answer, or the question answer session can be put before 5 itself. The organizer can make it very clear so that I can plan myself actually. Hello? Hello?
Sir, you can go up to 5 o'clock, sir. No problem.
Okay, fine. No issues. So that the phases and everything, I'll make it out. And I suggest the participants to have a piece of paper and pen with you, so that here we are, and with all my tributes to Srinivasa Ramanujan on his birth anniversary week, let me start the thing. Though, and at the same time, the present day's topic owes much to the machine learning, artificial intelligence. Let me pay my tributes to Alan Turing, who is the father of computer science. And because of him, we are talking up, because of Ramanujan, we are talking about some knowledge, intelligence, and other things. Because of Alan Turing, we are talking about, artificial intelligence, machine learning, everything. So with all the tributes to both the legends, let me start my drama and let me upload my first slide. I'll be switching over the slides. And the idea here is, what is in my mind is concept to code. First, we will be thoroughly understand the concepts. After that, how this concept gets transferred to the code for the real-time implementation. That is the agenda. And I have taken a very heavy topic, support vector mission, and which is a very powerful classifier algorithm for linear data set and non-linear data set. Everything will make it out. And I will, even if there is a participant, sir, I don't know anything about machine learning. Just now I have joined in BTech first year, no problem. All these techniques are going to be from the scratch level. And what we cover, we'll understand thoroughly. That is the thing. And others, if I'm not able to cover certain things, I'll send the content to you, so that you can, if you have any doubts, you can contact me. In all my slides, I have my phone number, I have my email ID, everything is there. You can feel free to contact me. Let me share my slides first. let me, I think that entire screen. Whether my slides are visible, just see here.
Yes, sir. Visible, sir.
Is it clear? Linear classifier, that was the first part actually.
Yes, sir. Yes, sir.
Okay, fine. So now, and the agenda in the first point, what I'm going to do here is, and I'll have, this is the way the drama is going to happen. First, let me give a brief introduction. Time is 3:35. For 10 minutes, what is classifier, what is the classification, those things. And we'll propose one new problem, maximum margin problem. Then how to find out the solution for it. And first, we will find out the solution through the primal of the problem. After that, for our comfort's sake, we will have the duality of the problem with illustration. Then after having covered with linear classifier, if there is time, we'll go for non-linear. There are two methods in it, soft margin and non-linear SVM. And these things we'll cover slightly. First thing is linear classifier. The name itself suggests, for example, for everything we will have, this one I'll show one data set, sample data set. For example, this is one data set. Are you able to see my screen actually? For example, this is one data set. This is called, are you able to see my screen comfortably? Are you able to see my screen? Banknote authentication. This is the name of the data, the name of the data set. What is the thing? Every currency, like our rupee notes, the images are taken, and from the image we have found out the statistical measure, variance, skewness, kurtosis, entropy, and other thing. And finally, using these four entities, we are going to classify whether it is a real currency or a fake currency. Hope you are getting this. You are able to view this data set. This data set are available everywhere actually, just to give a glimpse how a data set will be. For example, marks of a student in a class in 5 subjects. It is a data set. And every row will give the marks of a student in 5 subjects. Like that, these things are called futures. That variance, skew, kurtosis, entropy, they are called futures or parameters. Different names actually, or there are also some people call that as a constraint. Now the idea here is, in machine learning, the classifier problem is, I am giving one currency note image whose variance measure is 3.6216. Am I audible or not? Am I audible? Am I audible?
Yes, sir. Yes, sir. Continue, sir.
Very good. So actually, this data set tells you $1 currency is image is taken, and these statistical measures are calculated. 3.6216, 8.6661, minus 2.8073, minus 4.446999. So I can call this as a 4 tuple, or it is a data point in a 4-dimensional space. That is the thing. And this data set tells you this note is a real note. And when you go down, if it is 0, it is a real note. This is called output variable, or this is called dependent variable. Like we have y is equal to f of x, x is independent and y is dependent. This class is the outcome. We usually refer it by r. And this input variable we call by x. I mean, I'll call this as x2, second data set, x3. So x3 is one point in a 4-dimensional space. And as we go down, this data set contains the details about the fake. See here, go down. This is a very big data set, around 800 plus. Just go down. We'll have this. Now, these are all fake. So how this data set is created? By taking the images of a fake currency and a real currency. So now what for this data set is going to help us? Tomorrow in a bank, one person is submitting one currency. That is a fake currency. They'll take the measures of it, and based on this classifier model, they will recognize whether it is a fake currency or not. That is called the concept of classification. It's something like I go to the market, I purchase tomato, potato, onion and garlic, everything. And when I purchase from the market, I put everything in the same bag. After coming home, I segregate and put it in a plastic cover and put it inside a refrigeration. That is called a classification. If I buy 4 vegetables and put everything in one bag and come and segregate, it is called 4-class classification problem. If I have only 2 classes, it is called 2-class binary classifier, like that actually. So this introduction with this data set concept, and I'll share this linear classifier. See here. So the same thing, I'm going to make it out. So first thing, how to find out. Slideshow, I'll make it out. So instead of a data set, I am abstractly representing the data set. Capital X is equal to XTRT. Please minutely listen. All the concepts which are explained should be thoroughly understood. If there is any question, please stop me. Don't compromise in the conceptual understanding. Whether you do AI or machine learning or whether thermodynamics or computer vision, there is no compromise for conceptual understanding. If you lose the understanding, you can't get onto the field anyway. Please be careful. I'll make it out. And the prior knowledge required to understand this concept is basic 12th class mathematics. Maxima minima knowledge of mathematics is more. Here we have taken one problem, which is an application of maxima minima problem. Function of several variable instead of function of, in the 12th class, you would have done in a function of a single variable. So capital X is the whole data set which I showed to you. I am going to represent that as capital X, and this is small x. The suffix T tells you first data point, second data point, third data point, indexing. And this is the output. That is, output, and how many data points are there? N. So I told you, it is a 4-dimensional data point, 4 tuple. So x1, x2, and so on, x3 is an element of Rd. So x is a d-dimensional vector. And R is equal to 1 or 0. So in the example I showed you in the data set, bill authentication, currency authentication, fake or real currency, if it is 1, it is a fake. If it is 0, it is a real currency. I call this as class 1, class 2. So data set is given to you and it contains details of the real currency and the fake currency. Now, if I show one new currency, the model algorithm should tell me whether it is real or not. For example, I'll go to the data set again. For example, if I give a data set minus 3.917, see the item number 931, minus 3.9172, 2.6652, 0.78886, minus 0.7819. If I give it, the model will say that is 1. But I'm going to give a data point which is not in this data set. That is called classifier prediction. I have to predict the class. The same thing goes with classifying the healthcare system data. The hospital has got a huge collection of all the data sets of all the patients. So they have the height, weight, age, gender, locality, and body mass index. All these things. It can name all the things required to identify whether a patient is having a disease or not. To name, I'm having a data set about the cancer-related patients. So using the data set, if new patient comes tomorrow, I will measure all these parameters and use this model to conclude whether the patient is suffering with cancer or not. That is the thing. So now if I apply for a loan to a bank, they will get all the information, my age, how many years of service are there, how much savings I'm having, how much collateral properties I'm having, all these things they will get. And the bank manager, you can use this classifier model and conclude whether this customer is a reliable customer or not. If the model tells I'm a reliable customer, the bank manager can have no hesitation in granting loan for me, so that they will have a confidence and that I'll repay the loan. So the classifier model is applied in all walks of life, actually. Right from buying vegetables till I construct a house, and you want to, in a class of, there are 3,000 students or 4,000 students studying in a program at an engineering college. And I want to know which student is a good student, intellectually powerful student. I can use this model. Only thing, accordingly, I have to take the data set actually. So now coming back to this discussion. So now, so these are the classes. So now, for example, yes or no, pass or fail. See, so first understand the terminology. R stands for dependent variable. X stands for input. X may be one dimension or two dimension. It depends upon. In general case, I have taken a D dimension. And here I am talking about the two class problem. And see here, I have got the data set. All the points, it's a two dimensional point plotted. All the data point can be plotted as a point in a graph. So now I have, for example, these are the things like C1, C2, I am making a mark like a circle with the X actually. Now this is a data set. The whole data set is plotted as a graph. Okay, now I want to put a classifier which can classify without any doubt. So if I'm able to draw a line which separates, for example, on one side, all the class 1, C1s are coming. Or on another side, all the class C2 are coming. So it is called, so the equation of the line in two dimension, ax plus by plus c. Instead of ax plus by plus c, the new avatar is w1x1 plus w2x2 plus w0. So w1, w2, they are going to be called as the coefficients or weights for the corresponding, how much importance I have to give you. For example, in an assessment system, there will be two mid-exam, one final exam. Mid-exam will be given a weightage of 20%, and final exam will be given a weightage of 60%. Like a weighted arithmetic, we are having W1, X1. Plus, this is an equation of a line, simple equation of the line in two dimension, ax plus by plus c. What we studied in your analytical geometry, the same thing. Instead of ABC, I'm using W1, W2, W0, and W0 is called the bias and the intercept and other things. So this is called the linear discriminant because a line can separate it actually. If it is a higher dimension and other things, what I can do here is, for example, this is a multi-class dimension thing. For example, how many classes are there? C1, C2, C3, three class problem actually. For example, H1, hyperplane. If it is a two dimension, I'll call that as a line. If it is a three dimension, I'll call it as a plane. If it is higher dimension, general term, I'll call it as hyperplane. Because the number of dimensions for the real-time use will be 400 dimension. For example, the ChatGPT use 17 billion parameters. The dimension of the data set is 17 billion. The present ChatGPT, which was given out by OpenAI, and the Gemini also is huge. Of course, our Zoho Indian company is interested in giving a low parameter model problem, language model problem with 7 billion. Low means don't think that it will be in 100 and 200 actually. Just for now here I am making it two dimensional just for us to understand. The whole drama will be escalated to a very powerful higher dimension, which we can't visualize it. Only for that reason, we are doing the computation with graphical, GPU, than the CPU, we prefer GPU. And this tensor process, the Google's Gemini model, which came out last week, 13th December, it uses TPUs, tensor processor actually. What my mathematics, what we study vectors, tensors, those things are really converted into a real-time application for a powerful AI product. We have to be very proud, but at the same time, we can't keep just by taking pride in ourselves, but we have to understand how these tensor concepts are put into real use. That is the concept. Okay, very good. So hope you understand the difference between two-dimensional problem, two-class problem. The one which is in the screen is a three-dimensional problem. And for every dimension, for example, see H1. On H1, one side, you are having only class C1. On the other side, non-C1 will be there. H2, hyperplane. Since it is two-dimensional, I can call that as a line and other thing. But usually the general term which I refer is hyperplane. H2, one side, C2. Other side, non-C2, like that actually. So now here, this is a data set. I'm going to give a definition, linearly separable data set. You have a data set in the form of a table. Hope this data set can be plotted as a point in a graph as per the dimension. Don't bother whether I am able to view that dimension, higher dimension. Only for that reason, since you can't view that high dimensional graph and other thing, we are taking the help of algebra. We are converting that into equation and doing the things actually. Because For example, I can have 17,000 equations with 17,000 variable with 17,000 equations like that. I can comfortably do in algebraic method than getting visualized in the, what do you call that, graphical mode actually. So this is the concept actually. So now here there is a data. Hope now I understood what is this plus and minus. Plus belongs to one class and minus belongs to one class. And there is a data set on the left I am having. This data set can be separable. So separable with the help of line, linearly separable. So line means algebraically we say that, don't, for heaven's sake, don't have an idea that line means only 2 variables or 3 variables. It can, it's a function of several variables. I can have any dimension, but it is a degree 1 equation. So I can, for our understanding, since we can visually, because my laptop monitor is a 2-dimensional rectangle. So, for example, if I want to draw a sphere in my laptop, I'll draw a circle and say this is a sphere because my laptop screen is 2-dimensional. So, like that, first understand this data is linearly separable. And here on the right-hand side, we are having a data set which is distributed where a line cannot separate. Or instead of a line, I can call that an equation whose degree is 1. That cannot be done. Am I correct? This is a non-linearity. Hope you understood the concept now. So now, given a data set, so the problem boils down to, given a data set X is equal to xt or t, n number of capital N stands for the total number of data points, X stands for the input data, every X is a vector, R is a dependent variable. For our consideration case, only one dependent variable and many independent, and the X is independent variable. And the classes are denoted by C1, C2. If it is C1, the output value will be 1, and if it is C2, 0. C1, C2 are the 2 classes. So this is the, now how I will go about it. So I propose one classifier. What is the equation of D variables in degree 1? That is the hypothesis. W1, X1, for example, if it is 2-dimension, AX plus BY plus C. Now, instead of it, W1, X1 plus W2, X2, and so on, plus W2, X3 plus W0. So it is an equation of a hyperplane. I'll give the status as a line actually, because of degree 1 actually. Now I'll compute the objective function. This RT minus G of XT means what? For example, in the fitting the curve, what we have done here is, RT is the output, and what is the value of this hypothesis for a particular point? That is called G of XT. Like f of x is equal to x square. F of 2 is what? 2 square. The same thing. XT stands for the tth data point. It is a vector. So I find out this is the value predicted by the hypothesis. This is the value given in the data set. The difference between these two are called error, and this difference can become minus or plus. To get over this minus positive from my minus and positive problem, I am making a square of it. This is a square cap square, and this is the error generated by 1 point, and I am sum up all the errors and making it actually. So this is called the error for the hypothesis G when it is trained by the data set X. I mean, it's a probability expectation actually. Now, using this thing, I have to find out the unknown thing. This X1 is known to me, X2 is known to me, XD is known to me. This is given in the data set. X1 is the value of the first component in the first row. X2 is the second component, like that. So what is the unknown thing? W1, W2, W2, W0. D plus 1 items are unknown. I have to calculate that parameters such that this error is minimum. Once that is minimum, we'll find out. For example, to understand this, you just see here, this is one, I'll make it into a data set. So for example, this is one data set. I mean, it is a price versus engine power. Okay. Now, what is the thing? Can I make a classifier? Here, the classifier is a rectangle. So now all the price of car, this is a car data set. All the price of the car whose price ranges between P1 and P2 and engine power lies between E1 and E2. They are the positive example. So this belongs to positive, that is circle. Inside the circle, there is a positive. So that says that is one class. So this is the hypothesis. I have to find out the value of P1, P2 and E1, E2. If I find 4 values, the problem is over. And when a new car comes, okay, for example, P1 is 10 lakh, P2 is 20 lakhs, E1 is 4.7, E2 is 8.2. So if any test data comes, if that falls within this range, I'll say it is a positive. Like that actually. Here the class name I'm giving positive, negative actually. So how many people will compete for this P1, P2, E1, E2, any value? Infinite number of n tuples are there. So we have to find out those things. For example, here is learning with a circle. I have made it out. This is a circle with center C and radius R. The circle is a classifier here, learning with a circle. So now, for example, if there is actually, there is a data set, the data set is converted into this graph, and using this graph, I am making one learning here. So since just these are some few number of data so that I can understand the whole concept very clearly. So this is what circle. So if it, I mean, all the people who are sitting inside the circle belongs to one class, one category. And all the people who are outside the circle, they belong to another category. How could I know that? Plus and minus, just to distinguish, I have written actually. So what are the parameters of this learning? C and R. What are the parameters of this learning? W1, W2, these are the parameters. So in the machine learning algorithms, don't think that the machine learning model is great or AI model is great. In AI or machine learning model, we are going to find out the values of the parameters. Just computing the parameter in such a way that error is minimum. What is this error? Error is the function defined by this. This R is the value given in the data set. G is the value proposed, predicted by your hypothesis. Sir, how many hypotheses you can take like this? How many equations are possible in degree 1 of D variables? Plenty of hypotheses. So if one hypothesis doesn't work well, you change the hypothesis. How the doctors treat the patient. It's a pure machine learning thinking. First, they with all the symptoms. Instead of symptoms, we call that as a parameters or weights. And they predict something. They make a guess that is called a prediction. They start the treatment. Then they will ask us to come again after 3 or 4 days. We come again. If the illness is gone, I'm safe, no problem. If not, we'll go to the doctor. The doctor will change the hypothesis. Same thing like machine learning also works in that. Machine learning, deep learning, or they call that artificial intelligence. Everything does. We propose, work it out, compute it, and if it is not comfortable, if it is not successful, what we do here is we'll change the hypothesis. That is the concept actually. So like that. So now, for example, I am going to learn that unfunction in the digital circuit theory, unfunction. That is, I can also, this unfunction, this is tautology, we will be making x1, x2 true, 0, 0, 0, 0, 1, 0, 1, 0, like that. I want to learn this. For example, in the 10th class exam, we'll give the function and ask to calculate, for example, f of x is equal to x square plus 1. Find the values of the function when x is equal to 4, 5, 6, 7, like that, I can make it. Now the data set is going to be given. You have to compute the function. You have to learn the function. Why we call learning? Because there is no strict formula. If it is 4 data point, I can do it. You are going to be given a data set with 20 billion data points. So we have to propose one function which will fit this. So for example, I'm making this equation. What is the hypothesis I'm making? Ax plus by is equal to 0. So x is 0, x1 is 0, x2 is 0. So first equation is b is less than 0. Then w2, what is the thing? What is the general hypothesis? w1x1 plus w2x2 plus w naught. W naught, I'm representing it by b here. So I am generating 4 equations. If it is 10,000 data points, 10,000 equation. How to solve a system of equation with the 10,000 points, and the number of unknowns will not be equal to the number of variables. So these problems will happen. For example, so we'll solve it and find out. So these are the thing actually. So now I think that with this idea, we can go for the support vector mission. So far, have you understood the first is getting over? Have you understood what is support vector? What is a classifying model? And what do you mean by linear classification? What do you mean by non-linear classification? 2 or 3 minutes, I can wait. If there are any questions, please clarify. Am I clear in that? First thing, we have touched the bird's eye view about machine learning classifier algorithm, how the work does it. Any questions? I'll be happy to handle there and then actually. Any questions? Now we are, and just now we are getting into the support vector mission. Can I go ahead? Can I get any response? Unmute yourself and you can make it out. Actually, the AI tool which you are working is, now I'm not sure, I can't get a facial expression whether the students are hearing my talk or something like it. So we are, at present, we are in the process of developing AI tool where we can measure the facial expression and estimation and come to a conclusion whether students are listening or attending or not actually. That is the thing we are working at present. That is also another classifier algorithm. That is the thing. Can I get a response before I go for the next gear? Hello? Hello, can I get a response from anyone? Just, I won't ask any question. And I don't put it in the chat box actually, because I can't go to the chat box again and again and get to know it. Anyone can unmute whether the first concept you are clear or not. Because this classification concept, you are making it. Okay, very good. Some people have raised their hand, I think.
Sir,
okay.
sir,
Yeah.
sir, because of huge participation, we have unmuted the participants.
Okay,
At the end of the session, they will put in the chat box, sir.
Okay, fine. They are showing the hand actually. Some people have shown. All the best. Let me go for the next. Okay.
Thank you, sir.
Okay, now. So now what I'm going to do, the hero is going to enter into the situation now. So we are, and slowly I will make it out. Up to 430 linearity I will complete actually. So this thing you can, for the sake of completeness, I have put. So again, it is a classification problem. Certain things cannot, all the data set cannot be handled by a linear hypothesis. So there are certain things which can't be handled by the linearity. Linearity means what? Degree 1 equation. That is the thing. If you have any confusion, how that non-linearity means what? For example, this is a linear equation. For example, I can make this way. Are you able to see my whiteboard? For example, this is linear. This is non-linear. And for example, this is non-linear like that. This all. And if you take the algebraic equation represented by this line, it will become of degree 1. Number of variables, don't bother. That is not a part of the game at all. Don't have any idea. Degree 1 means what? You know what you mean by a polynomial in one variable of degree 1, polynomial in several variables of degree k or something like it. So this is the non-linearity concept. And if I draw a graph based on the data set, if the graph comes like it, I can call that as a linear. It's not a straight line or something like it. And here it is a non-linear actually. And this is non-linear, those things actually. Okay, very good. Now coming back to the point actually. So now I'll make it out. So which I showed it. So now there are two concepts, linear SVM. It is a classification algorithm. It is a classification technique. It is a classification model. It is a classification program, algorithm, model, system, whatever name you call, you can make it out. What is the work of that? If it is given some data, input data, it has to classify and say it. For example, if I give one, when I am having a two class classifier model, which can separate tomato and potato, and if I show one potato to it, it should correctly say this is potato. Image of a potato, if I show it, it should say it actually. And what is the problem here is SVMs work on the concept maximum margin hyperplane. So now we are going to propose it. We are going to study about the concept. What is the concept behind support vector vision? For 5 or 10 minutes, please give a focused attention. Once, because most of the ML people, ML students, they find it difficult. Only for that reason, I have taken this. Very easy, provided you catch the point. So there is a data set. And for our understanding, I am going to focus only on 2 dimensions. Very good. A1, A2. A1 is one axis, A2 is another axis. I have taken the data point, and I can have many hyperplane which can separate. Am I correct? This is a linearly separable data. There is a data which can't be separable which can't be separated by linearity. Even linear separable problem is an open problem. Given a data set, even now this mathematicians are it's an open problem till now. There is no technique with which we can say the given data set is linearly separable or not. Yeah, machine learning consultant, data scientist is there. When data set comes, he wants to train that apply the classifier model to the data set. So he first thing, he should know if it is linearly separable, he has to start the hypothesis with the degree 1. If it is non-linear, non-linear means what? Degree 2 or degree 3, degree 4, nobody knows what is the degree, because it's a random real-time data set. If I'm generating a data set with a computer program, I can comfortably say it. But the one with the data collected for the health sector purpose, data collected for real estate purpose, data collected for the retail recommendation purpose, we don't know how the data set is going to be black or blue or length or weight or something like it. So now there is a data set, 2-class problem. And so when I show this graph, you should have an idea. There is a data set in the table format. There are many parameters. How many dimensions? It is 2 dimension. So A1 is 1 column, A2 is 1 column. There is the output column, like that. Actually, how to visualize it actually. So how many hyperplanes are possible? Many we have drawn it, and you can also draw in many ways actually. So the task is you have to draw a straight line which will separate the data clearly, no overlapping and other things. So now, which is the best hyperplane? Are you getting the question or not? Are you getting the question or not? Now see this. I have written 2 hypotheses. H1 is one hypothesis. Please, we'll spend 1 or 2 minutes more for this slide so that you can get the point. H1 is one hypothesis. After H1, on both sides, I have held a dotted line. That dotted line is called the decision boundary. And I represent this red color dotted line with B2 to B12. What do you mean? What is this what is this B11 and B12? First index in suffix of B stands for hypothesis 1, decision boundary 1. And second thing, B11 and B12. Focus on the red color marked one. This also separates. Now focus on H2. Hypothesis 2, which is marked by the green color. That is also separating. Of these 2, can anyone say which is the best separator? Which is the best separator? You have your own logic. Oh, I was told that you are under mute. No problem. Okay, now I will carry on. Here is, in the red color thing, there is one fellow sitting on the border. That is, for example, if I mark the paper, pass mark is 40. If the boy gets 39, what temptation I'll have? I'll go through the paper again. I'll see whether I can add one more mark for the boy, so that I should not, by mistake, the boy would have written, I would not have seen the paper or something like it. When the boy is close to the pass mark, I'll have those doubts. When the boy gets 98 mark, I won't go through the paper again. And when the boy gets 4 out of 100, I won't go through the paper again. So there is in the red color hypothesis, just see 3 red color lines. One is a continuous line and 2 lines are dotted line. And this is H1 is called the equation of the hyperplane. And this one sitting on the dotted line is called decision boundary. So now this boy is sitting in the on the border itself. B22, there is a border. B12, the thing. But whereas nobody is in the border, in the green color thing, just see here. So there is no ambiguity. It's very clearly separating, because I want to prove that what is the difference between this and this is, here I'm making a, what is the thing, one line, and I don't have a decision boundary. Now I am making a margin. What is the difference between the earlier figure and other thing? Just a separator. Okay. So now to decide which separator is best, which lines does the separation in a perfect way. So for that, whose help I am taking? I am taking the help of the margin. On both sides for equidistance, in an equal distance, I am making a boundary. So this, from the region between the left dotted line and the right dotted line, I am going to call that as a margin. And I want to say that this data set should be separated with the width. For example, assume that. This is the best example I can give in any of my class actually. Prime Minister is visiting Bapatla. And the police are interested with the bandobast. and the GBC road, the Prime Minister is going to travel. What the police will do? They will put the barricades on both sides of the road. And they won't allow. Prime Minister is going to travel in the mid of the GBC road. And both sides there are platforms. Hope the same situation is there in the GBC now. I don't know what is the present context of the GBC road now. My idea is last time I visited in 2015. After that, I have not come to Bapatla. So just assume a one highway road, both sides are barricaded. Police will be interested not to allow anyone in that road. The distance between that in the region between the left barricade to the right barricade, they want to keep it as a no man zone or no women zone. Am I correct? So that only if that is the case, they will be having confidence on the security. They won't have anyone near to the barricade also. But here in the red color bandobast arrangement, one fellow is sitting on the barricade. One fellow. So the police will not keep that out. So here in the green color, that is the thing. So now of these two, H1 and H2, H2 is preferable. There is no problem about from any of the data point. And the green color middle line is the place in the path going to be taken by the Prime Minister's convoy. But if the Prime Minister takes the convoy route H1, one fellow is sitting on the barricade. At any time, he may jump into the convoy. So they don't want to. So now, for a better classification, what we are going to do here is, we are going to separate the hyperplane with a big margin. That is called maximum margin problem. Can you get the point? So I want to see, for example, I'll go to the board actually, whiteboard. Just see here. The data set is there. The data is there. I want to draw a hyperplane and I want to make a margin. The dotted line I'm making parallel lines, and this also parallel line. I don't want any data point to fall within this region. Hope you are able to see my cursor marked. Any teacher who is able to see can give me a confirmation. Dr. Sarathi sir, you are able to see my cursor point. Hello. Hello.
Yes, sir. Yes, sir.
Are you able to see my cursor movement on the board?
Yes, sir. Everything is clear, sir.
Very good. Very good. Very good. So
Thank
now,
you,
when I want to find out the equation of the hyperplane, this hyperplane, such that no data point is in the margin. So all this side, all class, maybe plus, all people should lie in this. This side, all other class, two class problem, I'm going to take it out. So if it is a potato tomato problem, all potato should be in that side, all tomato should be that side actually. And nobody should be there in this region. This is called boundary. I want to, given a data set, I want to find out a hyperplane whose margin is very big, maximum margin hyperplane. Hyperplane is the equation of the middle line. Why I told you, no, instead of, sir, you are drawing a line, you are calling a hyperplane, hyper aeroplane or something like it. Just to visualize in the high dimension, no real-time data will be two-dimensional. Can you get the point? Every real-time will have many input parameters actually. So that is the idea. So the problem here is maximum margin hyperplane problem. So now coming back to the thing. So now I am quoting this problem. Now we are going back to the 12th class now. 1 minute, we'll make it. Problem is given the training data set. As I told you, training data set is going to be abstractly represented like this, XTRT. T stands for the item number, fourth data, fifth data, something like it, and other thing. Now I want to find out a hyperplane such that what is now instead of, for example, this W transpose in the linear algebra model, W is a column vector whose transpose. This is what WTX plus W naught is nothing but W1X1. This is the thing I mean it out actually. So instead of writing like this, I can make it, for example, I can make it here W1X1 plus W2X2 plus and so on, W7 X7 plus 1 by s. Usually we'll also, the algebra will say constant term, W naught. Instead of writing like it, I can make a column vector here. Am I correct? W naught, I can write like this, W1 and W2 and so on, W7, and I can column vector, and this one, X1, X2, and so on. Take the dot product. Are you getting this equation or not? So now I can make it WT X plus W naught. Yes or no? Just a representation. So that is the thing I am making it actually. So this is the equation of the hyperplane. W1 x1 plus W2 x2. X is a vector with the d-dimensional input. WT is the thing. When you take the dot product, I can make it out. So, and where to find, I want to find out a hyperplane such that, now what I am making it, for example, that is a hyperplane. Just see here, this is my problem. I am having a data set. This value is, for example, the value of the hypothesis -1 in this region. And this side, it is +1. So I want to have a separation here. And this side, at the same time, the value of the function will be 0 actually. So now this idea, I am making it like this actually. Pure 12th class. WTXT plus W naught is greater than or equal to +1, less than or equal to -1. If it belongs to one class otherwise. So now what I am going to do, So now what? So now just I'll quickly to find a hyperplane W2X plus W naught is equal to 0 such that now I can combine both the things and make it out, because less than or equal to, if I if I multiply with -1 both sides, I can have it greater than or equal to, I can combine these two equations. So the task is to find the hyperplane whose equation is this for every t. For every data point, I have to find out an equation such that the values of W are satisfied for all the points. And we don't consider 0. That is the thing, because 0 means we can't have anything. So now what I do here is, just I'll go back to the workboard. So I want to find out the margin. What I do here is just hyperpoint. There is one data point here. So now what I do here is, I'll find out this distance. I want to make it out one side. This is the distance between a hyperplane and a data point. Am I correct? In 2-dimensional, I can say that distance between a point and a line, a plane. For example, in 2-dimensional geometry, ax plus by plus c is equal to 0. There is a point 4, 3. What is the distance between the point and the line? What is the distance? Same thing. For example, if I have a point, equation between a point and a plane, you are more comfortable. I will make it this way. For example, ax plus by plus c equal to 0. And there is a point 2, 3. What is the distance between this 2, 3 and shortest distance between 2, 3 and this line ax plus by plus c? We will substitute wherever x is there, that is 2a plus 3b plus c is divided by root of 2 square plus 3 square. The same thing, equation. That's a 12th class formula which I have written here. So now, why I want to find out? I want to find out the margin such that all the points are to the left of margin or to the right of margin. That's a no man's zone when the Prime Minister visits Bapatla, travels with the convoy in the GPC road. The same thing which I have done it actually. So I find out what is the point which is nearer to that. I find out the distance. I want to make this distance as maximum. If this distance is maximum, then the margin will become maximum. So that when I classify the data set, there won't be any ambiguity. Nobody will be sitting in that. Very good. Fine. Now coming back to the thing, that is the thing I am making it in the next slide. Don't think that it is pure math class, but concepts are very, very important for computer scientists. If nobody would have understood the concept, this ChatGPT cannot come. 17 billion parameters, please. So let xt be any point, one random point. G of x is a hypothesis. The distance between xt and the hypothesis, this is the thing. Hope this is the thing. The distance between a plane and a point in 3 dimension, or distance between a line and a point. If there is a line ax plus by is equal to c plus c is equal to 0, and there is a 2 and 3, you just substitute wherever x is the 2 and wherever y is the 3 divided by the absolute value. instead of absolute value, this is called W transpose in linear algebra concept, or W dot W, norm of W. So now we want this distance to be bigger than some number. Because this is the distance. If this distance is maximum, what will happen? Margin will become maximum. So now I want the distance to be maximum, means what I can do. So for example, I am taking one row. You say that row is 4.5. Then my distance should be bigger than 4.5. And there will be some people who wants to play the game with me. They'll say row can take 4,782. Then also the distance should be bigger than that 4,782. And I would have got a friction with some student. He will say that 4 followed by 18 digits, 9999999. Then also this should be bigger. Only then I can claim for maximization there. Am I correct? So it should be bigger than a bigger number, like you do in real analysis. Because the real analysis was the topic which I have taken more for MSc people at Bapatla Engineering College. Walter Rudin, thanks for that. Okay, now. So distance become RT. The RT is the output, just this is a mine plus or minus 1. So I have made it out. This is the thing. Our idea is to maximize rho. So by changing the values, we can make it. So now, if rho is fixed, we can't fix that row, and there will be plenty of values I can take it. So I want to restrict, narrow down. So I make it the denominator as 1 actually, rho into norm W, just for my convenience only. Now, when I make, so now I want to, instead of maximizing the row, we can minimize W, because rho and W are connected by row product W is equal to 1. If you are going to maximize rho, I can minimize W. Simple, I mean XY is equal to 1 technique. So now I am making it the problem now. So now we have to minimize. Earlier we started with maximizing rho. Now I am coming with the concept of we have to minimize W such that this is. So if you want to minimize, so now we have to minimize W such that. Now, instead of minimizing W, can I minimize W square by 2? For example, there is a function. Function f of x attains the maximum value at the point 4. When the function f of x whole square will attain the maximum at the same point only, or when for example, I'll go to the whiteboard for your clarity. So there is no drama here. For example, I am having one function. I have found out the maximum value taken by the function f of x is equal to x square over 4. It takes maximum value, and the domain will be given 2, 4, means at the point 4, it takes the maximum value. Now I am asking when f of x over 2, what is the value, maximum value of this f of x by 2? If this is in the domain, for example, in the region 4, 5, when the function takes the maximum value 4, 5, at the point 5, function takes the maximum value. Now, I want to know f of x, for example, f of x whole square. I'm sorry. F of x at the point x is equal to 5, where the function will be maximum or not. So you manipulate f of x, the maximum point will always be maximum. So when you want to find out, just 1 minute. So I want to minimize W. Instead of minimizing W, I can minimize W norm W square by 2. Why I am making it W square by 2? Because margin is made up of 2 things. Now just see here. I'll go to the board now. The margin, we just see here. This one, I found out the margin by this distance only. Am I correct or not? The margin is made up of this distance. I'll make an assumption both are equidistant actually. So now this distance norm W square divided by 2. If one side is maximum, both will be maximum only, because I'm making an assumption equidistance actually. So I found that. So all are common sense. So instead of maximizing W, I'm minimizing W square by 2 subject to the same condition. So now the problem boils down to, so hyperplane, middle of the line joining margin is, so we have to minimize W. So the problem, this is the problem, sir. The problem formulation is W is a column vector, W0, W1, all they are unknowns. X are known to us, subject to the condition. For every T, if there are 10,000 data point, for every T, this condition has to be satisfied. So the problem, a real-time application of classification problem has been converted into a maxima problem, maxima minima problem. So it's a thing. Now we'll take a break and go to 12th class mathematics. For example, what we do, if we have the 12th class maxima minima problem, Lagrangian multiplier, if there is a constraint, usually if the problem is without constraint, we'll find out the first derivative, second derivative, stationary points, those things we find out the maxima minima. But it is a constraint problem, and constraint is with inequality. This condition, subject to the condition, involves inequality. So we'll go to Lagrangian multiplier. Usually, if there is a condition, what we do here is, this is LP is the Lagrangian equation. See, what is the objective function? Norm W square by 2 minus what is the condition? I write down the condition with the condition. What I do here is I write down alpha t, and I am making it. That's all. So I am making, so the method of, I'll go to that thing. This is the best example I can give you. I want to I minimize one function x plus 2y subject to the condition. Here the condition is what? It is an equality constraint. Can you get the point? So what is the Lagrangian of it? We introduce a new variable called lambda, and lambda value we have to find out. L of x comma y comma lambda is equal to the same function we write x plus 2y plus lambda of the constraint I am making it, and I find out dou L by dou x, because the independent variables are x and y, and lambda is also in favor. Lambda is called the Lagrangian multiplier. So dou L by dou x, dou L by dou y, dou L by dou lambda, and I'll calculate lambda, y, and other things. And using this normal thing, the function has its minimum value. At this, the normal, this thing I'll share with you, don't bother. Actually. Now, inequality constraint. Now, we are having a problem here. Constraint is not equality. Just see here, constraint is inequality, greater than or equal to. So now what I do here, there is an inequality constraint problem. So it is something like it, minimize. We just carry the idea from mathematics for computer science. That's all. Minimize function subject to how many constraints? You can have any number of constraints. Here, our problem has only one constraint actually. Subject to h1 of x, like that actually. So now I am making, for every data point, I have to have a lambda. For every constraint, one lambda will be there. Am I correct? How many constraints are there? P constraints. What is the index of the constraint? h1 of x, h2 of x, h3 of x, like that actually. So lambda 1 h1, lambda 2 h2, lambda 3 h3, like that. Don't feel bored. It is not pure max. It's a powerful max which is getting applied in the modern day. So really, if without mathematics, world cannot function. Without mathematics, AI cannot do anything. Without statistics, there is no AI, machine learning, deep learning, nothing is there. Even that's what I'm telling. Based on the tensor product which we study in mathematics, the Google has created a tensor processing unit. CPU, GPU, TPU. Please understand the concept. So we have more steps. Only thing is, if we understand the whole concept and apply for a problem, there won't be any great intellectual person than the mathematician. Yeah. For example, 2 days back, Narayan Murthy, Infosys founder, has raised the question, why there is no Abel Prize winner and field medal from India? During the Infosys Foundation prize distribution, he was raising one question. Because the problem is the conceptual understanding, we are getting weak actually. So only for that reason I'm making it actually. I'll show the code and the drama of everything. That will take another 15 minutes. That's all. Don't worry about it. Hope it's not boring, I think. But I can't get a feedback because they have unmute. I'll wait for the question answer. So now, how to solve the problem of inequality constraint optimization problem? So you have to find out the objective function like it, and we have to find out the derivative as we do in the normal maxima minima problem. All this thing we have to find out the lambda I and other thing. For example, one example I have written, f of, very simple example which anyone can understand. F of x comma y is equal to, that's constraint is x plus y less than or equal to 2. There are two constraints, y is greater than or equal to x. So based on that thing, I'm making first write the objective function plus lambda 1 of one constraint x plus y, you just bring all the terms to one side of the left-hand side of it, and lambda 1 of x plus y minus 2 plus lambda 2 of x minus y. And what are the constraints? These are the constraints. What is the thing? Because we have to find out the values of lambda 1, lambda 2. So for that, we want to have a system of equation. So dou L by dou x, dou L by dou y, all this thing. Hope I would have done the derivative correctly. Don't bother. You can check it later, actually. And based on the things, I'm calculating lambda 1, lambda 2. And if this is why lambda 1, lambda 2 is not a feasible solution here, because one constraint is lambda I should be greater than, lambda 1 should be greater than 0 or equal to 0, lambda 2. This is the constraint given here. Lambda I should always be greater than or equal to 0. So that is the thing. So we'll find out all these things and make it out, actually. So now we have, first we proposed, proposed the problem, and how to solve the problem. We went to 12th class mathematics, maxima minima with the equality constraint, one illustration we just now saw, and the maxima minima with what do you call that, with inequality constraint. So this is the thing. Now back to the maximum margin problem. So this is with a Lagrangian multiplier. How many multipliers? For every data point, there will be one alpha coming into the picture. See the thing, index is t is equal to 1 to n. For x1, first row in the data set, I'll have one alpha 1. Second row in the data set, I'll have one alpha 2, like that actually. And so now how to solve this problem? So instead of solving this problem, I can, because how many parameters are there? How many unknowns are there? W will have d unknowns, depends upon the dimension of the data set. W0 is 1. And how many for unknowns? If there are 10,000 data points, 10,000 unknowns will be there. So it is very heavy. We have only one parameter like alpha, we can easily solve the problem. So now what is the thing is, if we have the situation in many of the operation research problem and other thing, primality, duality, they will change the problem into dual of the problem. And the solution for the dual will be the solution for the primal also. So the stage 3 is formulating the equivalent dual problem actually. So now these are the things which is already available in the mathematics textbook only. So now the dual problem is this one actually. So dual problem is alpha t is what? Alpha t rt xt whole square plus constraint. Each derivative should be 0, because for finding maxima minima, the same concept of static derivative should be 0 at the tangent to the at point of tangent to the derivative. So those things, we'll have an equation. So solving any equation, we can find out alpha t for every t. This is the thing actually. So now I'll come back to the thing actually. One example we can say. Now I'll say what is the support vector. Now the solution, these things and all, instead of going for the solution, I have come with an illustration itself. This is one data set with how many data points? 3, 5, 8 data points. So it is a 2-dimensional data point. So this x1 represents certain things in the real time, x2 represents certain things in the real time. Don't worry about it. It can be price of the car or engine power or whatever it is. It depends. So let me propose a hypothesis. This is the crucial part. Even if you have missed out anything, you can understand easily from here. So let g of x is equal to w2 x plus w0. Very good. G of x is equal to w1 x1 plus w2 x2. The same thing. There's no difference between matrix representation and this thing actually. There x is a 2-tuple, x1 comma x2. Okay. Now what I do here is I'm going to propose a hypothesis. Then after the hypothesis, just see here, what is the thing I have to do? After the hypothesis, I have to write down the Lagrangian multiplier. This w, everything is there. This x is known there. X is known there. W0, w are unknown there. Alpha is unknown. The same thing. So now what I do here is, so I'm making it a Lagrangian multiplier for every input variable. I have to make it out actually. X1 is the first row of the data set. Let the multiplier be L1, for the second L2, L3 like that. Don't think that it is alpha A. Alpha square, it is not alpha square, it's not alpha, superfix 2 is not alpha square, it's the second thing. So now I am making the dual of the problem, which I have written. LD, duality of the problem, the Lagrangian multiplier is minus 1 over 2 summation. What we have done what is the solution given here? I am just making it. This is the same thing, I am carrying it out actually. What are the constraints? These are the constraints. Partial derivatives is 0, and sum of alpha and our output and the Lagrangian multiplier, sum of the product of alpha and r's are always 0, and every alpha is going to be greater than or equal to 0. Agreed or not? So now just see here. This illustration will solve every ambiguity in you actually. So now I am making it LD is equal to, I am making it, I am just making it. What is alpha 1? Alpha 1 is unknown. R1 is, what is the first output in that? R1 is +1. R2 is -1. R3 superfix I am writing -1. And R7 is +1, like that. I am substituting all these values here. So let LD is equal to, I am just writing what is the A square here and other thing. I am solving. These are the constraints actually. So I differentiate with, calculate the values of alphas. I differentiate each with respect to independent variable alpha 1, which are unknowns here. All the alpha 1s and other things are unknowns actually. Then A is equal to this thing, 8 equation. And what is the thing? We have to solve this 8. For every alpha 1, I'll be getting one equation and I can solve it. And based on the solving, I have got alpha 1 is 65.52 because I'm not showing the working of that. You can solve it the same way, you will get it 65.52, and all the other things are there. Now, here, now the concept of support vector. Which are support vectors? Support vectors are the points. See here, I have defined here. The XTs. XTs means what? They are the rows of the data set whose corresponding alpha is greater than 0 are called support vector. Those are the people who are going to find a place in the margin. The police has to take care of those people, support vectors. They, at any point of time, they can jump into the pathway of the prime minister. And if alpha, for every row, I will have an alpha. If that for our data point, alpha is equal to 0. Alpha cannot be 0, cannot be less than 0 because of the Lagrangian constraint actually. A Lagrangian multiplier can either be 0 or greater than 0. For example, if there is a data set, this is the margin. See here, this is the margin. This is the margin. This is the margin. If there is, if I take this as a hyperplane, and if there is a data point sitting here, that fellow is called support vector. And if there is a point here sitting in the margin, inside the margin also, that is called the support vector. So usually support vectors are not from heaven or hell. Support vectors are from the given data point only. So they are from the given data point only. So what is the thing happening here is, we have identified the support vectors here in this problem. So for example, I'll make this now. So now see here, if I calculate this value of alpha, these two are the support vectors. So the 0.38, 0.47 and second data points are their support vectors. And all the points are outside the margin. So now this is the, for example, when you expand the margin, definitely there will be you may say that, sir, why can't we have a margin in such a way that even the support vector, they don't find it? Then the margin will be shrunk actually. So for this equation, this is the thing. I will calculate those values. And then pure max follows now. And we have to calculate W1, W2. So I resubstitute alpha values. W1 is equal to this. From this solution, we have found out W1 is equal to, so W1 value I have calculated alpha t, RT, X1 t. And if I know the value of alpha, I can calculate W1, W2 and other things. So using the values of alpha, I can find out all these things. I can make it out. So W1 comes out to be minus 6.64. W2 comes out to be minus 9.32. And I can calculate W0. W0 is what? W0 equation, just see here. W0, for each data point, I can calculate the W0. W0 is equal to RT minus WTX. This is T stands for first data point, second data point, like that. So I can find out, if there are 10,000 data points, I can find out 10,000 values of W0. and based on that, I can take the average. So take the average of all that shall be the value of. So like that, I can make it out here. So W2. So now W0 in the first thing, I'm making it 7 point here, incidentally, it is coming the same value 7.93. So equation of the hyperplane with the maximum margin is minus 6.64 x1. This is the thing. For that data set, this is the separator. We can't have a separator beyond this margin. How many support vectors are there? Two people are sitting on the boundary itself. If you expand the margin, then the classifier cannot identify correctly. There will be overlapping and other things. Can you get the point? So support vectors are the whole in the maximizing the hyperplane margin, we have found out the support vector. With this support vector are going to be the borders of it. So this is the equation. For this data set, I cannot have a margin bigger than this. Can you get the point? That is the thing. Agreed. So this is the thing we are making. The life is very simple, very agreed. Now, if it is a linear separable, no problem. If it is non-linear, if it is linearly not separable, what to do? So for that reason, kernel trick is there actually. Before, for example, this is the thing, non-linear data set. I can draw it. For example, this is a non-linear hyperplane with this equation of the semicircle, non-linear hypersurface. With one illustration, I can go for non-linearity actually. For example, we just see here. That left data set, I am making it what? There is a data set. It is separated by a circle and instances are separated by a circle. Here, I can't separate it by a line. On the left-hand side data set is linearly not separable. Yeah, with a one single hyperplane, I can't make it out actually. So I want a hypersurface actually. Very good, fine. Hypersurface means you can understand that it is a non-linear surface. That's all, finished. That the degree alone, nobody can predict it actually. So now, before that, I will make it out actually. Fine. So for example, just see here, I can make this left-hand side equation, assume that the area of the circle is 0.5 and the radius is 2. So let the equation of the circle be x1 minus 0.5 whole square plus x2 minus 0.5 whole square is equal to 4. That is all the points which lie inside the circle. That is less than, that is less than 4. I'll say that it is a negative example. Greater than 4, I'll say that it is a positive example. If it is equal to 4, those points lie on the circle here in this. Now, what I can do here is, this is non-linear. What I can do, I can take a transformation. For example, the equation of the circle is what? I can expand this. Please, just 2 seconds it will take, you can understand. X is in class plus 1. Class plus 1 means what? This positive is greater than 2. Because x1 minus a whole square plus x2 minus b whole square is equal to r square, the standard equation of a circle, and I'm making it actually. So equation of the circle is, I'm just expanding the equation. Now what I do here is, I am making a transformation. I call phi1 of x is equal to x1 square minus x1 plus x2 square minus x2 is equal to 0. I can do it or not, that I can write that as z1 plus z2 is equal to 0.46. Can I do that or not? I am applying a transformation phi1. Phi1 of x is equal to x1 square minus x1. This x1. x1 square minus x1. First 2 terms I am making for x1 and second thing for it. So if you transform all the data points from x space to a z space, both are 2-dimensional. Then the equation of the hyperplane is z1 plus z2 is equal to 0.46. Now, z1 in the z space, what is the thing? It is a linear separable. Are you getting the point or not? So, non-linear mapping, if the data set is non-linear, to classify them, we can use a transformation. That transformation, they call that as a kernel trick. Trick means just we are going to do magic with the mathematics. So, the standard terminology itself, kernel trick, they will say that, or kernel, they will say simply actually. Am I correct? So now what I do here is, I'll go to the thing now. So now I'll go to the Google Colab notebook. See here, the codes and all, the Python language is very comfortable with the code and you can understand very easily. Don't worry about it. And all this data also in this notebook I have written actually. For example, I have generated one data set, sir. See here, are you able to follow here? Just see here. And I have generating a data set. And it is a data points in two concentric circles. How many points I have generated? 500 points. How many noise? How many deviators? Because when I generate data set, I have to say that it is, I have to make it noise will be there. So there will be some 0.02% of the data points. They don't fall on the exact circle. This way, that way, there will be deviation. Am I correct? Are you able to follow? Here, what is the thing? Now, can you separate these data? That is, when you plot the data point as a graph, it takes the shape of a concentric circles. With these things, the libraries you can make it. This is the NumPy NumPy and sklearn libraries are there. You can say again. I'm telling no need for coding, but you can understand how the things are working here. Now you'll wonder. Now what was the thing for the non-linearity? What did we do from a two-dimensional XY space? See here, from the two-dimensional XY space, X1, X2, we converted into a Z1, Z2 space by using this drama, phi1 of x. Now, there is another question, sir. How could I know that since this is a two-dimension, I am able to understand if it is 100 dimension, 2000 dimension, how? For that, we are having libraries, don't worry. All the trial and errors will be worked, but there we depend upon the computation. There is a fellow called Stupid Fellow with a TPU brain. He will do all the sultry works for it. Only thing we have to feed him with all the work all the time, actually. Because these things cannot be manually done. Please understand that we require high computation power. Now coming back to that, this you can enjoy, I think. Now here, see here. So now I want to now as if the day, as if if you see the data set, it is not linearly separable. Of a degree equation 1, I can't make it out actually. Now what I can do, I can increase the dimension. For example, earlier I was having x1, x2 as the 2-dimension. Now I am making x3, third dimension is, just see here, cursor point of this, I am highlighting it also. You are able to see my Google Colab notebook, I think. x3 is equal to x1 square plus x2 square. And I am making it. After that, I am making this, using the matplotlib, I am making the plot, display the plot actually. And these things are the visualizing data in higher dimension. So from the 2-dimensional data, I am going to visualize in the 3-dimensional data. How does that happen? How does that happen? We just this. Now I have made it x1 square plus x2 square as the third axis. I can take any axis for my choice. They're the coordinate axis. Like where we have x, y, z. We are having x1, x2, x1 square plus x2 square. Am I correct or not? Are you getting the point or not? Now you plot those points. 500 dimensional figure it is. Because how many points I have taken in samples? 500. Which we can't visually draw it on the paper and pencil. So now, can I request the organizer to unmute so that I can get the reply for this question, at least 1 second. After that, you can mute them. Now, data, the same data, and the idea here is the data. Data is linearly not separable. Very good. After that, I transformed into a higher dimension. And what is the third axis? x1 square plus x2 square. Now I plotted the graph. It comes like it. Now my question is the data separable or not? Linearly separable or not? Can I get a response? From the figure itself, even if you're not understood anything, no problem. From this figure, you can understand, easily tell me. Hello?
Sir.
Yeah. Hello? Just 1 second. Sir. So that yes, sir.
Allow mic for attendees. Camera.
Hello?
Okay, 1 minute, sir. 1 minute.
Yeah. Just so that they can visualize the data set immediately.
Mic for attendees.
Okay. Okay, sir. Allowed, sir.
Hello, respondents, can you please tell me again? Let me make the thing. Originally, I have created data set. See here, generating data, XY, make circles, n samples, and other things with the noise. Noise means some points will be deviating. 0 to 2%. Yeah. Hello, can I get a response? One response.
Yes, sir. Yes, sir.
Now the data set is transformed into a high dimension. Now my question is whether this data is separable or not. Are you able to visualize this figure? First, the data points look like a concentric circle. After that, I have increased the dimension and plotted the same point. Third axis is x1 square plus x2 square. Are you getting the point or not?
Separable, sir.
Separable.
Separable, sir.
Okay. Now
Separable, sir.
now see here in the thing. Now organizer, you can mute them for a second so that during the question answer we can make it out. So that there are
Okay,
extra
sir.
sounds are there.
Okay, sir. Okay.
Okay, just one. Now I have applied the SVM library available in the sklearn. Sklearn is the is a library developed for all this purpose. See here, and from sklearn import SVM support vector mission library. I am importing, and it's like a function subroutine. Without coding we can practice all the data science. Actually, all the things which you want are already available in the form of a libraries actually. So I am using this SVM thing, and I am making it linear. See here, when I make it x1, x2, I have made the separator equation of the hyperplane. See, two rings are there. In between, I am making one plate. That is initially the data was non-linear, but I projected I transformed that into a higher dimension. Because of the projection to the higher dimension, the data becomes separate. The two circles, the concentric circles, one has gone up. And if you want the yellow to go up, you can do the transformation like it. See here, this x1 square, x2 square is my trial and error. You can make it x1 cube plus x2 cube also, it is up to you. So with all the trial and error, I can easily see how the data is behaving. No need for a theorem proof also at this stage. You can see, you do some change in the concept, you just check the data set, visualize it. Because I was told there is another talk during the week-long conference, FDPs, there is a data visualization. You can also learn many things. There are plenty of tools available. So that once I gain the insight, I can make it. Are you able to make it out? So support vectors are there. So support vector, these are the people who are sitting in the border. There are 10 people sitting in the support vector in this margin. Or 10 people are lying in the margin. So the support vectors are the people who are going to lie in the margin, and this is the maximum stretch I can have it. How many support? See, if there are 1,000 data point in a data set, support vectors will be a few actually. All they are the people who are, I'll coming back to the theory here. They are the people whose, this is the thing, I'll make it this way. So they are the people whose alpha value is greater than 0. Support vectors definition is what? And if you want to make the margin as maximum as possible, there will be certain points whose support vectors are, they again I'm telling, support vectors doesn't come from heaven or hell or something. They come from our own packet. From the same data set, we will have the support vector. And for each data point, I can have the alpha. So x1 will have one alpha 1, x2 will have alpha 2, x3 will have alpha 3, like that. And the data point whose alpha value is greater than 0, that is called support vector. And in this Google Colab, just see here, how many support vectors we have that has identified. 500 dimension problem, 10 support vectors, it has come out actually. What is the dimension of it actually? What is the dimension of this? It is a 500 dimension problem. From the 500 data point, from 2 dimension to 3 dimension, we have projected it and we have made it out actually. So now the same bank data set, that classification, I told you, the bank authentication data set that we are taking, that is using the data framework. And I want to find out and how many, for example, usually in the training, if there are how many data sets are there, there are 762. That is, this is the data set I am talking about here. There are 762 data points here. Before we wind up, I'll show this and wind up actually. 762, this data set contains 763 points, that is starting from 0, 762 records, which are real nodes whose dimension are carried out. And we can get all these things from this Google Colab actually. I'll show my notebook actually. Yeah. So 0 means real node, 762 starting from 0. And there are 610 fake nodes actually. Now, usually what is the thing? How many things actually? So it is 1,372 data points are there actually. So now I run the thing. I say, for example, SVC classifier, it is fitting. SVC classifier dot fit X train, Y train. If there are 1,300 data points, what I do here is certain data points, I use it for training. Something like, for example, I am teaching maths for the 12th class student. I am having 100 problems on calculus. What I'll do, of the 100 problem, 50 problem, 75 problem, I'll teach. I'll teach all the 70 problems. If I'll take one problem, I'll tell how to do this problem, discuss in the class, and 75 problems, I'll take it. Remaining 25 problem. So this problem with which I teach, that is called training data set. And 25, I am having total number of 100 problem for the course. 75 problem I discuss with the students and make it out. Remaining 25 problems are there. I use it for conducting examination from myself. That is called validation data. And tomorrow, the board exam, intermediate board exam will give some problem. That is called test data. So usually what is the thing here? The trained data is 20% test size. That is, of the 1,300 data points, I am making it 80% for my training. That is, I use it for plotting these points and those things. For example, these are the points which I have taken for training, with which, like a teacher does it. 100 problem, 80 problem, he teaches in the class. 20 problem, no teacher will ask the same problem discussed in the class. There is no thrill in it actually. So 20 problem, he will be testing whether he understood or not actually. And the board exam will be a brand new problem actually. So training data, test data, validation data, test data. So this, and I will check whether the boy has learned or not based on the exams got in my mark. If the boy gets 100 and 100, 100 out of 100 in all the tests which I conduct, then I'll say their parent, the boy's parent, sir, your boy is doing very well. He is confident of centum in his intermediate exam. Like that, I can make it based on the thing. Like that, this, what do you call that? This is made it out. So this, what is the accuracy? Thing is 99% accuracy. It is correctly classified 153 correctly and 122 fake note. 0 is a real note, 1 is fake note actually. Like that, I am making it all. They can make it out actually. Now coming to the last part of the thing, 1 or 2 minutes more actually. Sir, when this projection happens, all these things, sir, how could I know that? For example, just see here, another example I can give it to you. I'll make it. I'll go to the slide 1 minute and come back actually. Now, just see here. Just see here. Sir, how the same thing in general I'm making it x1, x2, x3. This the transformation I'm making it. Sir, here I have made a transformation. Phi1 is equal to x1 square minus x and phi2 is equal to x2 square minus x2. How could I know that this transformation will work or not? That is the $1 million problem. Even in this notebook example, see here, this happens very clearly if I make it this way. For example, this happens very clearly if I make the third dimension like this actually. x1 square. x1 is one dimension, x2 is another axis, x1 square plus x2 square is another. How could I know that I have to make it x1 square plus x2 square? Why not it can be root x1 plus x2 power 7? That can also be the third axis. So this is only with the trial and error we can make it. This is called kernel trick. That is the for non-linearity, the kernel tricks are being made like that. Just before wind up, kernel tricks, I will make it out. So this kernel, here what I am making it, this kernel I will make it out a k of xy. I am making a transformation. It is that is, I am going to transform using a polynomial of degree q. So this will be the transformation. So I can make it for, these are the standard thing. Polynomial of, polynomial of 2. Polynomial of degree 2, q is equal to 2 here. Q is equal to 3, like that I can make it out actually. And so now, just see here. I am making this separate for a kernel of degree 2 like that. So these are the standard this thing, linear kernel, polynomial kernel of degree p, Gaussian kernel, Laplacian kernel, sigmoid kernel, and Mahalanobis kernel, like that we are making. See here, this from the figure you can understand. If I make a polynomial kernel, how does this separate the plus and minus? Hello? Any disturbance? Just I'll wind up. Hello? So see here, polynomial kernel, you see here, the left hand side is not separable with the line actually. Now I am transforming to a polynomial. Now this happens to be separable like it. Now see the sigmoid kernel. Sigmoid is of the S-shaped function where the value ranges between 0 and 1 actually. Now you just see where the plus and minus are there actually. Only with the S-type curve we can separate it. Separation means what? One side all positive, another side all negative. Can you get the point? So now here, this is the thing. And sigmoid kernel. And the Laplace, and see the Gaussian RBF one, which is the one which we saw with the example. So with the circle, I can make it out. From the circle, from the two dimension to two dimension, I can make it. Laplacian kernel. I can make it like this actually. These are the kernels. Actually, there is no standard way. So for this data set, this kernel worked with the trial and error. Again, I am telling doctors diagnosing technique is the only way out in machine learning also. If one hypothesis doesn't work well, I have to redo the work with another hypothesis and make it. Hello? Hello? Hello?
So, sorry,
Hello?
sir.
Hello? Hello? Fine. So there is a disturbance, it seems, actually.
Sorry, sir.
Yes, sir. I am looking at it.
Okay, fine. So now, I think that, see, you can appreciate, hello? You can appreciate this, I think. So by different kernel, for example, left-hand side is the original data set, is minus, plus, minus, no line can separate, it is a non-linear data set, actually. I can use a polynomial kernel, and polynomial kernel is what actually? Just see here, this polynomial kernel is this. With the p is equal to 1, I can make this, p is equal to 2, p is equal to 3, p is equal to 4, like that I can make it out and check how does the work well. Sir, for which degree polynomial? Again, the computation power is there. We can do the trial and error and get to know that actually. The sigmoid kernel is a very beautiful thing. See, how the data points are there, no line can separate. So now it is separated with a S-shaped curve. Just this border, just see here, see cursor movement. This is called sigmoid kernel. Sigmoid kernel transformation is what? It is tan hyperbolic, tan h. Beta naught xt, and beta naught instead of w, I have used the word beta. Beta 1 is the bias. And this is the kernel actually. So now this is called kernel trick. And the transformation is also like it actually. Now I'll make it out. I'll show one more notebook and I wind up now. 1 minute. I'll go to my Google Colab. I'll open another file in my Colab. Open notebook and non-linear. One minute. This is the thing. I'm making it. 1 minute. I'll go one more. I have one more file. I'll show this is open actually. See here. This is, I have generated a random data set and I am making it. First thing, this is the scatter plot of that graph. After that, what I do, I am making a kernel with a polynomial of degree 2. How does that separate? Just see here. Actually, it has not done the work nicely because there are many people in the margin. Am I correct or not? Are you able to find out that blue color is one and this is another, there are two different colors. They belong to different classes. And this is the separator, this is the margin. And I have made the kernel as polynomial of degree 2. See here, in this code, I can show where I am making it. SVM, kernel is equal to poly, degree 2. That means this function is applied there. This function, polynomial x, that is x, instead of xt, it is wt. xty plus 1 whole power 2. So now just see here. I'll go to my notebook. Here. So polynomial of degree 2 is my thing. How after separation, this is the separator, hyperequation of the hyperplane, but this doesn't work well. There are plenty of confusion. Prime Minister is going, many people are inside the margin near the convoy. Police can't keep mum. Now I do the next thing. I'm making it polynomial for a linear thing. I make it somewhat better. Like that, I have to change my kernel and see the observation. I have changed this linear. Degree 2, that was, this is degree 1, linear is degree 1. In the cell number 16, you can see it actually. Now I separated margin hyperplane. Comparatively, it is better. I am not saying that this is best. So with the trial and error only, we can make it out. Are you able to visualize this data set? I have separated the data point, but there's no, this performance is not that much nice. Because many people are, that's it. If I make a value 100 students paper, all the of the 100 student paper, 78 students got 39 marks. Then there is a, if I redo, if I re-evaluate it, definitely the people will get more marks or this way, that way. So like that, now from the polynomial of degree 2, I apply this cell number 16, I'm making it. See here, somewhat better clustering that now, the minimum number of people are in the margin. So now what I do here is, so in the degree 2 and degree 1, there is a problem. So I'll go for different types of kernel, which is given here. Just see here. I'll, before, just see here, I'll make this way. These are the different types of kernel: linear kernel, polynomial kernel, Gaussian kernel, Laplace, like that. This is the thing I can visualize with this. Am I correct? So we have to try all these things. Hope, so summing up, what is the classification model in machine learning? A bird's eye view, we saw summary. After that, with the help of maximum margin, we propose the classifier problem as a mathematics problem. Maximum margin problem, maximum margin hyperplane problem. And for that, we use the techniques of Lagrangian multiplier. And here the Lagrangian multiplier, the constraints are inequality constraint. So we made it KKT constraints. We took the results from the mathematics and applied. And with one illustration, we just with one illustration, we made it out. Am I correct? So now, and we found out this one with illustration. We did all the calculation. I'll send this so that you can go to leisurely. After that, life will not be rosy. All the data points will not be linearly separable. Again, linearly separable problem is an open problem. Those who are interested can put a hand attempt on that problem. If the whole world is waiting for the mathematician to come out with a solution for this, so that if the mathematicians come out with a nice solution for linear, that is, necessary and sufficient condition for the linear separable problem, huge amount of computation will be saved. That is the thing. And after that, nonlinearity, we did the trick using applying the transformation technique. The transformation technique In the computer science paradigm, it is called kernel trick or kernel or a transformation. And sometimes transformation can happen from the same dimension to the same dimension or to the higher dimension. With the Google Colab notebook, we saw the demonstration from the 2-dimension to high dimension, 3-dimension, how the things are changing drastically. In the 2-dimension, the fellow is not separable. The people will say that the boy is not hearing my words in the house. Parents will be murmuring always. But when the boy stands before the teacher will say there is no best student like him. He's the best student in the world. Like that, the data set, which is not linearly separable in the 2-dimension, is become a separable by the concentric circles move up, so that one whole new plate can be inserted in the middle, making the separation possible actually. But only thing is how that formula, third axis, in the notebook, I made it x1 square plus x2 square. So how those trick formula, kernel transformation function, for that only we depend upon this. These are the standard libraries which are available now. These are the things actually. For this libraries, in the sklearn library toolkit, we are having this already coded subroutines. We can use it like I have used in my Colab and make it out actually. So this is the thing. Any questions? Hope I have met the expectation, I think. But the things will get more clarified if you go through this content and the relevant textbook. The treatment, Introduction to Machine Learning, Alpeden is the book which I follow for this treatment and other things. And most, again, I'm telling C2C approach is the best approach, from the concept to the code. And you understand the concept, go to the code, and based on the understanding the concept, you just change the things actually. Like I changed, first I applied the polynomial of degree 2, polynomial of degree 1, like that, till I get a satisfaction. Again, doctor's diagnostics technology is your AI technology, trial and error. So the open for the questions now, at least the organizer can allow the questions, I think. Feel free to ask. If I know the answer, I'm going to say yes. If I don't know the answer, I get to know and mail you out. That's all. Finish. Don't think that I know everything. Open to the questions now. So I'm heading tensed up because I'm getting the feedback after 19 years from Bapatla's voice.
Okay. Respected L. Jagannathan sir, you have given a wonderful lecture of support vector machine A classifier, which enables us to know about the basic knowledge of support vector machine. This is the time for question and answer session. So, because of huge participants, we plan to post questions in the chat box.
Okay.
But chat box is not active now.
Okay.
So we are allowing one by one participants.
No issue.
Please raise your hands. Okay. Participants, you please raise your hands if you have any query. Dhanalakshmi, D. Dhanalakshmi. D. Dhanalakshmi, what is your question? Please ask. Please unmute your mic and we are unmuted. Sai Maithili. So please, anybody ask question?
Sir,
Hello.
Okay. Who is speaking? Who is speaking? May I know?
So, dear students, first introduce yourself and ask the questions.
ఆగట్లేదు వర్కింగ్ అది.
Sheikh Rizwana. Sheikh Rizwana.
ఇప్పుడు
Vishnu Topper ID.
Yes, Adi Vishnu. Akhila.
Hello.
The students.
Sir, my respected teacher, Dr. L. Jagannathan, sir.
Yes, sir.
We are all enlightened with your valuable talk, sir. Really useful to our students.
Yeah.
So thank you very much for your micro level point-to-point teaching, sir. We are all grateful to you, sir.
Thank you, sir. Thank you. Thank you. Now I'll send this PPT and this PDF notebook so that they can go through it. The points, they can work it out. The conceptual I have made, it's like a board, Blackboard working itself. I have worked all the points in the slides actually, so that anyone, any layman can understand with no heavy burden on mathematics. Just the results which are available in mathematics, we are going to see here. I have made all this thing with the illustration, because usually when you want to understand an algorithm, you have to start with one basic illustration like this. Like you have to work it out with the paper pencil, only then you can understand the functionality of this algorithm. Like it's a 12th class maths problem only. This is a data set. But of course, real-time data set will have thousands and thousands and thousands of data points actually. But we can visualize how the things are happening like that actually. I'll pass on those contents so that students can make it. And if they get any doubt in future, they can mail me through WhatsApp or message in through email. My mail ID, everything is there in the content itself actually.
Definitely,
Okay,
sir.
we will inform the same, sir.
Definitely. And if there is any other doubts related, if anyone who is interested in building a career related with AI, machine learning, based on the mathematics, because the world badly is in need of conceptually strong mathematician for building a powerful AI model. Actually, this with just run with the trial and error alone, you can't do the show. You have to have a concept. If you know how this algorithm is functioning, then only with that idea I can do the tinkering in the notebook. That is Google Colab, Jupyter Notebook or Colab, whatever framework you use. No issues actually. Can you get the point? That is more. And don't fear that how this complex ideas can be converted into a code. Already the codes are available. Actually, the thing is, almost all in the GitHub repository and our Git repository, every codes are available. And the customizing the code for our functionality itself is a great learning nowadays, actually. Can you get the point? So that idea, I think that these things will help the students a lot, actually. Hope my voice was heard in Bapatla, I think. All the best. It's a really nice idea. After 19 years, I left on August, got relieved on August 3rd, 2004, I think. Yeah, August 3rd, 2004. And I joined in the IIT on August 4th, 2004. Really, it was a good experience which I had in Bapatla. And the students, really, many students, like I'm very proud that one of our batch student has become the head of the department. Really, we only do it in this 1997 batch. I'm correct in the batch year, I think.
Yes, sir. Yes,
it
sir.
was 1 week or 1 week or 5 days. I don't remember. It was we gave the other departments also to start their Vishweshwaraya celebration also.
Yes,
Engineers
yes,
Day
sir.
celebration also. Really. Really,
Sir, you left 15 years back, sir, but still you are in our hearts, sir.
Very good, sir. All the best.
Sir, really good, sir. Really good.
Fine. Thank you, sir. Thank you. And welcome. You encourage the students to raise the question and contact me, sir. I'll be very glad to help you. Since I'm working in the domain, I can help in the computational sense also, in the abstract sense also. Whether they require help in the mathematical orientation, whether they require another thing is, I can make it out. And I wish Bapatla Engineering College Maths Department can organize one more workshop exclusive with the title Mathematics of Machine Learning. Like that,
Okay.
I mean, this SVM is a heavy concept. If you ask any computer data scientist, they will get afraid of this SVM actually, because the conceptually they can't catch the main point immediately.
Okay.
Only with the mathematics background you can make it out actually. That is the thing. Because I am moving with both maths oriented people as well as the computer science oriented people, and they come for the clarification. With the notebook, they say that for polynomial it is working like it. For this degree, if I change it, the data set behaving in odd way, how can it be like that? Then if we sit and understand the data set, only they can find out the flaw in it actually. Okay, I think that I have taken 20 minutes more. I think, sorry for it.
Yes,
All
sir.
the best.
No
Thank
problem, sir. No problem.
you. Thank you.
Thank you, sir.
Thank you.
Thanks, sir. Thanks you a lot.
Thank you. I think that I can wind up.
Sir, Janan, sir, thank you very much, sir.
Thank you. Shall I wind up? Shall I wind up?
Only few minutes, sir. Vote of thanks.
No, no problem.
Only few minutes.
Okay, no problem.
Okay. Thank you one and all for your good response and valuable support. Expecting the same participation for the remaining sessions also. Today's sessions concludes with vote of thanks by staff organizer Sri I. Potras.
Good evening to all. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. L. Jagannathan Sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, who gave such a good and informative presentation on support vector machine, a classifier. Despite of his busy work schedule, he gladly accepted our invitation and gave a valuable talk in today's session. Thank you very much, sir. I would like to thank our beloved head of the department and convener of this international workshop, Dr. KVLN Acharyalu sir, who guided, motivated, and supported us to do this program and encouraged us to shape out today's program. I would like to thank our principal sir and our management, Bapatla Education Society, for providing us all the facilities and encouraging us to conduct this program. Without their support, it would not be possible to conduct such a program today. Special thanks to Dr. P. Vijay Sardi sir, Professor, Department of Mathematics, for his guidance and comparing today's program very well. We are all thankful to Dr. K. Manideep Garu, Department of CSE, Bapatla Engineering College, Sri N. Kiran Kumar Garu, HOD, Department of MCA, Sri K. Sandeep Sardi Garu, Department of CBDS, Sri P.A.V. Krishna Rao Garu, Department of IT, Bapatla Engineering College, Sri A. Sai Kishore Garu, and Sri U. Venugopal Garu for their timely technical support to us for making today's event a successful one. Thank you, one and all.
And let me also thank Dr. Prabhakar Rao sir for shaped the department in the present shape, and he'll be glad had he attended it. And really, I put my thanks in record in absentia to him. And my sincere thanks to my colleagues, Dr. Karunagar, Dr. Srinivas Rao, and Dr. Sarathi, Dr. KVLN. These are the four people which I know, I think. Other names are new, I think, actually.
Yes,
Pratap, Bhaskar Babuji, those people are elsewhere, actually.
Yes,
Really, I cherish every moment of my being at Bapatla Engineering College Maths Department for 10 years. That is a great boost. And it's like an alma mater. I mean, it's a reunion-like thing. I had my full happiness in doing the thing. Hope I have met the expectations of the organizer, actually. All the best. Thank you. Thank you.
Thank you, sir. Thank you.
Thanks, sir. Thank you for that. Thank you.
Thank you, sir. Thank you very much.
Thank you. Thank you. Thank you. Shall I wind up, sir?
Okay.
Thank you.
Yes, sir.
Okay,
Thank
sir.
you.
Okay, sir.
Thank you.
So, okay, dear participants, we have just shared the feedback link in your WhatsApp groups. All of you go through the feedback link and fill the columns carefully and share the link, share the feedback immediately in your WhatsApp group. Thank you all.
Sorry, sir. Thank you very much, sir, for your excellent comparing
Thank
to
you,
make
sir.
this
Thank you very
program
much.
a grand success.
All the participants are requested to fill the feedback immediately. కొట్టేసామంటారా లీవ్ అంతే కదా
అంతే సార్ లీవ్ కదా సార్ ఎండ్ మీటింగ్ దట్టిన చూడండి